Alright folks, in this video we're going to be dealing with while loops and for loops and loops in general. To help motivate this, I try to use some more realistic examples and kind of get you on your way. And the three examples we're going to use is a loop that continues while the user wishes to do it again, the wisher, and a loop that does something until it can't do it anymore, which is kind of the definition of a while loop in the first place. And we're also going to use loops to do something some predetermined number of times. To motivate doing something while the user wishes to do it again, we're going to start by creating a character. Oh, I have a slash here. That says user wishes and set that equal to y. Pretty much every programming language has a while loop. There are usually variations like do while or until in several languages. In C++, and as far as beginning, I'm just going to focus on the while itself. If you need a variation of some sort, you can engineer it or go look it up. Anyway, I'm going to create this character. It can hold characters like y or n. I'm going to ask the user if they want to do something. And I'm not going to motivate what that something is. This could be anything from a math problem to doing your taxes to, hey, perhaps computing a tip or something like that, which I will assign for you as homework. And I'll say, hey, do you want to do something again? Whatever that something is, and then I'll read in that input from the user. Just like this, I'll maybe ask y or no up here. And basically what this is saying is, hey, do you want to do whatever it is again? And what the while loop is going to look like is it's going to say, hey, as long as this variable here is equivalent to the character y, then the user wishes to do whatever is inside this while loop. And so whatever it is that the user wishes to do many times is what the meat of this while loop is. This is the code you probably already wrote. So if you want to do the tip calculation multiple times, if you want to do the math, like maybe you're going to write a math problem thing, you can do math problems multiple times. And then you ask the user, hey, do you want to go again? The way this while loop works is when it first reaches the while loop, it tests this condition. And we know this condition is true because we set this variable equal to y. So yes, user wishes is y. It runs whatever's in the loop, and then it says, hey, user, type a character for this variable here. If the user types the character y, well, then this test will end up being true. If the user types the character anything other than y, then this condition will be false. So the code runs, it says, set the user to y, user wishes to y, test this condition, run all this code, test this condition, and as long as that condition remains true, keep running all this code. If this condition is false from the get-go, then none of this code ever runs. So like if I initialize this variable to n, or m, or anything other than y, then none of this while code will ever run because this condition will be false in the first place. So whenever it hits this curly bracket, it knows to jump back up here and test this condition yet again. And this is how while loops work. You can really make them work for you or do whatever you want. Just to show you that that's what's going on here, I'll go ahead and run the debug. But it's pretty straightforward. Where did my debug window go? It's way over here. Okay, do you want to do something again? Yes. And so as long as you say yes, it stays in the loop and it keeps executing it. But as soon as you type something else, like an n, and I typed an exclamation there, but anything other than y, it's going to quit the loop. One thing to notice is that this thing is case sensitive. So if you type the character capital Y, it assumes that that is not lowercase y because your test says, is it equal to lowercase y? Okay, this is a major reason that people use while loops. It's one of many things. But a large reason people use while loops is to do something until they can't do it anymore. So imagine you went to the ATM and you said, hey, ATM, give me all the money out of my account. Now, let's also assume the ATM only ejects $20 bills, okay? So let's say that you have a bank account value, bank balance of something like $513.65, okay? And you tell the ATM to spit out all the $20 bills. Then what it might do is as long as your bank balance is greater than $20, then maybe it will output a $20 bill, okay? After it outputs the $20 bill, it's going to update your bank balance by subtracting $20 from it. Minus equals is a shortcut for this, but I haven't really talked about that yet, so I don't want to do that now. But you can do minus equals in situations like this. So if you look at this code, it says, hey, the bank balance is $513, while the balance is greater than or equal to 20, output the $20 bill. So this is going to output quite a number of times. So let me go ahead and lower my bank account here. Let's say I only have $113, and I go ahead and run this. It's executing. This is the first loop. Do you want to do something again? I'm going to say no to get out of that. And then the second loop outputs 1, 2, 3, 4, 5 $20 bills. Okay, it does that because I had $113. There are 5 $20 bills capable of coming out of $113. Another cool thing that you'll notice is that bank balance is being updated as a result of this. And so you might say your bank balance is now whatever your bank balance is. Right? You can tell the user, hey, you just subtracted $100 from your account. The money is in your hand, so this is your new bank balance. So if we run this real quick just to show you what it's doing here. There we go. I'll say no. Your bank balance is now $13.65. This is what we expect when we started with 113 and subtracted 5 20s. Each time through this loop, it's subtracting 20. Let's walk through it one more time just to make sure that you get it. Bank balance starts out at 113, right? That means 113 is greater than or equal to 20, so it outputs this statement, and then it subtracts 20. So now bank balance is 93.65. When it hits this curly bracket, it tests the condition again. 93.65 is greater than or equal to 20. Outputs this. Now the bank balance is 73.65. Curly bracket means test this. 73.65 is greater than or equal to 20. Outputs to 20. Now bank balance is 53.65. Curly bracket, come up here. 53.65 is greater than or equal to 20. Output to 20. Now the bank balance is 33.65. Curly bracket, test, output 13.65. Now 13.65 is not greater than or equal to 20, so that's false. So it jumps out of this while loop and executes this cout statement, which is, hey, your bank balance is now 13.65. That's really how while loops work. This is probably the kind of one of the powerful explanations of how while loops end up getting used in code, which is they're used in situations where you can do something until you can't do it anymore for whatever reason. It's like, I'm going to walk to the end of the pier until there are no more steps to walk on. I want to walk to the end of this list until I'm at the end of the list. All kinds of places like that while loops get used. Another thing you can use while loops to do is to count. But often when you find yourself counting, you'll use a for loop instead. And so sometimes I motivate this with while loops. Sometimes I motivate it with for loops. I think I'll go ahead and just switch to for loops for now to show you this other syntax. It turns out that for loops are exactly the same as while loops as far as their capability of expressing things, but they end up getting used in different situations to more naturally represent the thing that they're trying to do. In order to understand how the for loop is going to work, you need to understand that there are 3 pieces that happen, and they happen at different times. There's an initialization step in the for loop. It's something that runs once at the beginning of the for loop. There is a test condition in the for loop, just like there is in the while loop. And then there is an incremental or end of the loop statement that happens. And so let's say that you wanted to do something like output the words hip as many times as the user wanted. So I'm going to ask the user for a number of hips. Okay? This seems weird. My inspiration for this is hip hip hooray, but let's just say. So we'll ask the user to input a number of hips. So let me put a number here. Okay, let's say number of hips. So what I'm going to do is initialize a counter, and this counter is going to start at 0, and it's going to increment each time through the loop until it matches this number. And when it matches that number, then I'm going to be done. Okay? This is how it works. You type for, the initialization step happens first. And what you can see here is that I'm declaring a variable called I and assigning it 0. This is the initialization step in a for loop. One thing to look out for is that a for loop has semicolons inside the parentheses. It's weird. It is a shortcut. It's useful in a variety of ways. And you'll see more of those down the line. So for int I equals 0, the next piece of the for loop is the test condition. And so this is just like the while loop condition. And I want this for loop to run as long as this variable I is less than the number of hips that the user input. Okay? The last step in the for loop is the incremental step. It's usually incremental, but it's some statement that usually relates to how the for loop increments towards the failing of the test condition. And in this case, I is going to be incremented by 1. I++ is a special shorthand that means the same as I equals I plus 1. So it takes the value of I, increments it by 1, and then assigns it to I. It's partly of how C++ gets its name. You know, it's an incremental step above C, I suppose, or at least in some people's eyes it is. Anyway, this is a for loop. And so what's going to happen is I is going to start at 0. If 0 is less than a number of hips, then the for loop will run. When I hit this curly bracket, then I will be incremented to 1. If 1 is still less than the number of hips, then the for loop will run. I will get incremented to 2. If 2 is less, then it will run. I will get incremented to 3. Eventually, whatever I is will not be less than this number of hips, and so it will stop. It will stop outputting. For the output here, I'm just going to output the word hip followed by a space. And then after the loop, I'm going to output endl. So this will end the line. So I'm presuming, or I'm telling you, that this will output the number of hips that the user inputs. So if the user inputs the number 4, there'll be 4 hips here. And I'm going to walk through why that test condition is true. But let's go ahead and debug and run it and look at it first. And then you can kind of verify that what I say is true. I'm going to say no. That's the output of my bills. And then the number of hips I'm going to say is 2. And so you can see hip hip. And then hooray. No, there's no hooray because I never output hooray. But you see 2 hips. Why do we see 2 hips? Well, 0 is less than 2, so I output a hip, and then I gets incremented to 1. 1 is less than 2, so I output a hip, and then I is incremented to 2. 2 is not strictly less than 2, right? So it fails, so I come out here and I do my endl. So I get 2 hips separated by spaces, followed by an endl. And actually there's a trailing space on the last hip, but you can't see it because it's just a space. So that works out just fine. You can do this with a while loop. If you were doing this with a while loop, you would declare your I outside the while loop. Your while condition would be while I is less than the number of hips. And then the last thing, or maybe the first thing, depending on what you're doing in the while loop, would be to increment I. And so this does the same thing that that for loop does. But the great thing about the for loop is that you can see the initialization step, you can see the test condition, you can see the incremental step, and they're all in one place. And so you know exactly how many times that loop runs or how that loop is going to run and change. And it's really kind of a tool for the job sort of situation. Most for loops that you see in any code have this sort of form where it's for I equals 0, I is less than some size, I++. I would say 90% of most for loops look like that. There's kind of a for each that gets written fairly often in a lot of languages, which does something for each element in a list of elements or something like that. We will eventually look at things like that. But I think that's it for this video. Hopefully you get something out of while loops. For homework, what I'd like you to do is go back to your tip calculator that you wrote and see if you can allow the user to do it again. Allow the user to recalculate a tip. Maybe you're with a group of people, you ran it once for your check, you want to run it again for their check, and make sure that it calculates all of these things appropriately. All right, that's it for this video. Have fun. Bye.